Hey, what's up nerds? Mike here. Listen, before you start with the lesson that you're about to watch, I just want you to know that it's actually a small part of a bigger course that I created on NSX-T troubleshooting. So if you like what you see in this course, check the description below for a link where you can buy the full course, and be sure to use the coupon code NERDYNATION, that's NRDY Nation, N-A-T-I-O-N. Use that coupon code and that will give you 70% off the regular price. Don't pay the full price, totally not necessary. That said, I'm gonna let you get to this lesson. I hope you enjoy it and come back for more. Take care and stay nerdy. I don't know what I was doing. I'm just gonna pretend I'm doing something important on my iPad. Welcome back. In this lesson, we are going to actually go through a live troubleshooting lab to solve a couple of actual problems within our NSX environment. Now let's take a look at a drawing just to understand what we are troubleshooting, and I guess first, how things are set up. So in our case, we have two VMs. We have Web01A and Apple1A over here, and both of those VMs are connected to the same T1 gateway in our environment. And I believe the one we're connected to, I believe it's called prod-T1. We'll confirm that just to be sure. But those are connected to this T1 gateway called prod-T1. And that T1 gateway is connected to this T0 gateway, which I don't recall the name off the top of my head, but it's there, you'll see it. Now that T0 gateway is then using BGP to exchange routes and reachability information to the physical network, which in our case is simulated by a CSR 1000V, but again, that could be, normally that would be a physical router in our environment, and that is completely outside of the scope of NSX normally. So all of NSX config is here. This is what I would call physical network. Now the other thing that you should know here, our goal here is that we want to be able to ping from both of these VMs. We want to be able to do something like this. So we want to be able to ping from Web01A through our gateway to our Tier 0 gateway, out to our physical network, and most importantly, out to the internet. In this case, we'll try to reach this IP right here. So 8888. That's our goal right there. And our goal is the exact same thing with Apple1A. We're going to try to ping through our gateway to our Tier 0, and obviously out again to the physical network to that same IP. Now, things that you should know that are relevant before we start troubleshooting. Both of these are not working. We're not having success, and we'll verify that, but I don't believe they're working, so we'll check and we'll troubleshoot and go through the whole process. The other thing you should know is that we do have network address translation, or NAT, on this segment right here, but we do not have any NAT over here. So there's no NAT on app-seg, and there is NAT configured on web-seg. That's just something we'll have to take into consideration as we troubleshoot. All right, so I'm going to clear this off. Let's flip over to the lab. Let's confirm everything. And you know what? I think we're going to start troubleshooting. Let's start by confirming everything is good on Apple1A. So we're going to start there, and then we'll flip over to the lab, we'll confirm everything, and we're going to start troubleshooting Apple1A's connectivity for now. All right, so here we are inside of the lab. Now let's go ahead, before we start troubleshooting, let's make sure we actually have a problem. So we said that we were going to start with Apple1A. Let's go ahead and launch a console. I've already got one up right here into that VM. And let's go ahead and just try to ping that 888 address. Now just remember, this is on the internet, so this should have to go through my NSX edge. This should go through my lab switch, firewall, and out to the internet. So let's run that. All right. Usually when we hit enter and we see just a blinking cursor, that's a bad thing, and that's certainly the case here. So this isn't working. Now let's go ahead, before we move on, a lot of people would stop right there, but let's make sure we troubleshoot this in a very smart way. So the first thing we should know, let's do IPA for this VM. That will just give us the IP information on this VM. Now this is on that 20 network. So let's go verify this in NSX. Right now we're just trying to understand how things are set up. So if we go into NSX, and we go over to networking, and we go down to network topology. We'll click that. This shows you basically what I had on that slide initially, which is, let me flip back, that's this right here. We have WebSeg connected to a T1 and AppSeg connected to the T1. Right now we're focused on this right here. So if we go back to the lab, we see AppSeg is right here. We see that we have a VM connected to it. That happens to be Apple 1A. And we can see the default gateway for that segment is right here, 20.20.20.1. And we know that that is on prod-T1. That's our gateway. So the first step before, we already know we can't ping, let me zoom out here. We already know that we can't ping from the VM through the segment, the T1 gateway, out the T0 gateway, out to the lab switch, out to the firewall, and the internet. We know that won't work. But right now, let's go ahead and just check, can we ping our default gateway, which actually lives on this T1 router right here, this gateway. To do that, let's go back to our VM right now, and let's just try to ping 20.20.20.1. And we can. So this is the first indication that there is something routing related going on more than likely. We can hit the distributed router for that T1, which happens to be on the same host. So if we go into vCenter, basically what we're doing right now, Apple 1A is located on London Compute 1. That's the host it's sitting on. On that host is a T1 distributed router, and it is representing this IP right here. So we're trying to ping that. It is successful. Okay, so that's good. Let's try to ping something outside of NSX, but not outside of the lab or the overall network as a whole. So not on the internet, but outside of NSX, somewhere between those two. So in this case, I have a DNS server, and that is the IP right there. And again, this is outside of NSX. This is on my physical network, but not out to the internet. Look at this. We can't even ping that. So we know now, if we go back, we know that Apple 1A can ping the T1 gateway right here, prod-T1. It cannot ping anything at all, essentially, past here. So anything on the physical network or that 888 address, none of that stuff, it can't ping. But let's do one more confirmation now. Let's see if something from the outside here can ping down and ping the T1 gateway also. Because if we can't ping it from out here, then we surely can't go, from Apple 1A out and then return, right? We need to make sure we check that return path. So right now we're going to check the return path, try to ping from out here into our T1 gateway. To do that, I'm going to just use my jump box, and let's go ahead and just give us some space here. All right, so let's try to ping 20.20.20.1. That's pretty interesting. We're getting this result, and this is actually, this IP is from the lab switch that NSX is ultimately connected to. So this isn't even making it to NSX. I'm trying to ping the T1 gateway, and just to show you on the diagram, my jump box is located out here. So all I'm trying to do is say, hey, let me ping that IP and get down here. It's stopping right here. So that's, again, another indication that we have some kind of routing problem. Now, of course, we can go in the CL or in the GUI and we can start clicking around and we'll probably identify the issue pretty quickly, but I want to walk you through troubleshooting this from the CLI. So the first thing I want to do is let's go ahead and open an SSH session into, let me close this. We're going to go into London Compute 1. That is our host. Again, that's the host. Let me just make some room here. That is the host that this VM is sitting on top of. So we're going to log into that host. All right, and from there, we're going to enter the NSX CLI command interpreter, essentially. So if we do NSX CLI, and this is very important, if you don't type that, the next commands won't work. So I'm going to hit enter there. And again, that's going to change our prompt here so that we are in that NSX CLI mode. We can see it went from here, it's now changed. Now from there, let's go ahead and we'll start with get. And we have a few options. In our case, let's try get. Let's do, how about logical routers. And what this is going to do is show us any logical routers that are located on this host. In this case, again, London Compute 1, where Apple 1 is sitting on top of. Now we get this crazy result here. It doesn't make a lot of sense to us. We see this UUID that's really long here. We see there's a few IPv4 routes, but it doesn't really make a lot of sense. What we need to do is do get logical router now. And then from there, if we do a question mark, we can see it's asking for a UUID. So this command is allowing you to get more detail about a single logical router. In our case, we only have one, so we're going to take this and we're going to paste that in there. Now, if we do a space and then a question mark, we have a bunch of very useful commands. And I want to point out, you probably noticed at the very beginning of this lesson, or a few minutes ago, I should say, let's go back right here, right? I started typing get F, get R, and you see the results I got, they weren't what I was looking for. I was looking for either forwarding or routing, not routing domains, just route or routing, and I got nothing. The reason is because this right here, when you do the CLI on the host, you need to say get logical router, specify that UUID. Now we have these options for all of these other commands right here. And in our case, the routing table on the host, and by the way, this is something I mix up all the time, is going to be forwarding. So what we want to say is get logical router this, forwarding, and hit enter. All right, what this is doing is showing us the routing table for our tier 1 gateway. Now we can see here that we know a default route, and we see a gateway here. We see that we have knowledge of the 10 network, and we have knowledge of the 20 network, so that's fine. So in our case, we know how to get out of this environment, but everything here looks generally good. We have a locally connected route to the 20 network. In this case, that's what Apple 1A is on. And we also see that we do have this default route leaving this environment. Now, one thing I do want to show you here, you see this IP, this 169.254.0.2. This is an automatically generated IP by NSX that allows it to connect between our tier 1 distributed router, service router, and then also our tier 0. But you see over here, it has this interface UUID. If you want to get more detail on this, so we're kind of doing a packet walk ultimately. So we're checking closest to the VM right here. We see our routing table looks good. Now, if we do get logical dash router, and we specify that same thing right here, our same logical router, and then we do, let's do up here, look at this, interface, and now we specify that UUID, that will give us more detail on whatever this interface is. So if I hit enter there, we can see that it says routing backplane. This is ultimately showing our connectivity between routing components. So we're on the distributed router now. This is likely on our T1 service router. That's the IP on the other end. Or more specifically, this is the IP on the other end. This is our local IP on this distributed router. So from here, I want to pause because it helps to conceptualize some of this if you use Traceflow. And that's what we're going to do. So we're going to go run Traceflow, one of my favorite troubleshooting tools, and then we'll use that to guide our next steps. So I'm going to leave this right here. Let's go into NSX, and let's go over to Plan and Troubleshoot. From here, we're going to go down to Traffic Analysis and down to Traceflow. We'll hit Get Started right here. All right, once we're here, we're going to leave protocol type to ICMP. We'll just change VM to Apple 1A. For destination, we're trying to ping the internet, so we'll change it from virtual machine to IP-MAC. And then we just need to change it to layer 3 right here. Once we do that, we can then put in our IP that we're trying to reach. And again, this could be any IP. In this case, it'll just be an IP on the internet. And I'm going to go ahead and hit trace. Now, to be fair, this is normally one of my first steps in troubleshooting, but I wanted to kind of walk you through a little bit of that CLI to start. And then again, we'll let this guide our next troubleshooting steps. Okay, so if we go up here, let's scroll all the way to the top here. Okay, so we see we injected a packet through Traceflow. That is the point of Traceflow. It injects packets for the purposes of testing. We see that it injected a packet at the network adapter of our VM. This is Apple 1A. It went through the distributive firewall. We don't see any drops here. We can see that the observation was forwarded. That's good. Now let's scroll down a little bit. We can see it goes through AppSeg. Again, this is the segment on that same host, all within that London Compute 1 host. It then hits the T1 router. That's the distributed router. It was then forwarded. We see it was then received by that backplane. That's what BP here. That connection. This is that. Let me go back here. We can see it's received by this interface right here. And we know that that means ultimately it was taking the default route and it's trying to get here. Okay, let's go back to Traceflow. We then see that it was forwarded from London Compute 1 onto the physical network. And look right here. Under IP address, we see local endpoint IP 1025.19.20 and remote endpoint IP 1025.19.53. These IPs are TEP IPs. This means that we encapsulated it with Geneve. We sent it towards our destination, which I know because I know this network. This is one of our NSX Edge IPs. This is one of the TEP IPs on our Edge nodes. From there, we can see it hits Edge 02. It's received. And we see the source and destination TEP details here again. Now, Edge 02 continues to process this and ultimately sends it to the T1. In this case, this is the service router component. And how do I know that? How do I know this is the service router component? Well, first of all, the service router component lives on the edge, and it's already gone and been processed through the distributed router once. It doesn't get processed through distributed router twice ever. I also know this is a service router because I see Edge Firewall right here. The Edge Firewall is a stateful process that lives on the service router. So that's another giveaway. Now from there, I see it matches this firewall rule 1002. It looks like it was successful. It was then forwarded again. We scroll down here. It is passed. So all of these transit lines right here are just showing kind of communication within the edge node itself between the T1 and the T0. So we see it now went from T1 to T0. If we scroll down a little more, we see, let's see, I'm looking for, okay, eventually the T0 SR makes the determination that we need to encapsulate this, and it sends it. Interestingly enough, look at this. This is something a lot of people don't know about NSX. We're on Edge 02 right now, right? Everything we've been doing up here has been on Edge 02, all of this. What actually happens here, let me go down. Okay, yeah, so what happens here, we were on the T1 SR on Edge 2. We went through these transit links, and this right here is actually the T0 DR, or distributed router. And if we click this, let's see. Yeah, we don't get any more detail here, but actually, no, we did right there. Look, backplane DR port. That's kind of our giveaway right there. Now, if we scroll down, what happens is Edge 02, so now we went from T1 SR, we went to T0, and then it encapsulates it, sends it via Geneve from Edge 02 to Edge 01. And that's what I was talking about. A lot of people don't know that it does that occasionally. So ultimately what happened was our T1 SR, our T0 SR, those components just happen to be active on different edge nodes. That's why this is happening. So we encapsulated it again, send it to Edge 1 now, And now it hits our T1 SR. And we can see that if we click it, we see, look, port backplane SR port. And again, the giveaway here is we see Edge Firewall, which lives on the SR T0. All right, so ultimately we see the result here is that it is then delivered to the physical network via this uplink on the T0. Now the challenge here, ultimately, I guess, let's just kind of review, because I know we went through a lot of stuff here. Now, ultimately what all of this means is that routing was fine within NSX. It got to the T0SR and it sent it out to the physical network. So the T0SR had some kind of route to 8888. We know that because it was dropped off to the physical network. If it wasn't, we would have said or seen, dropped no route to destination or something like that. So we know that routing going out of NSX is good, but let's just confirm just to be sure. So let's go ahead and SSH into one of our edge nodes. Let's go into edge 01. All right, from here, we're going to do a get logical-routers. And we can see we have different components here. We have a T1DR, T1SR, T0DR, T0SR. Now, what I want to do is look at this last hop. This was the T0SR. That is always the last hop when we're leaving NSX, completely leaving NSX to the physical network. So in our case, we want to enter VRF1, which is right here. So that VRF ID is very handy. So when I type in VRF1, that's going to drop me into this router right here, that component. So I'm going to hit enter. Now we can see the prompt has changed. It now says tier 0 SR. Now let's do get R. I'll do a question mark. Now we have that option for route. So we can see get route now being available. Let's type that in and hit enter. All right. Now we can see, let's go through this routing table. First thing, do we have a route outside? We saw right here, I said it dropped it off to the physical network. Do we have a route here to 8888? Yeah, we do, because we have this default route right here. This is going to this IP right here, which happens to be one of our physical routers that is not anything related to NSX. It is peering with us via BGP. We can see the B here, that's what that means. So that's how we know where this is going. Now, let's do get route question mark. We could also specify a specific prefix if we had a larger routing table. So we can just do get 888 or get route 8888, enter. This is going to tell us which specific route it will use for that destination. Well, clearly we have a route there. So this is fine. Now, I'm not sure if this would work from here. Let's try to ping 888. Okay. So look at this. So we can actually ping that IP from our tier 0 SR. So ultimately what we just confirmed is that we have, let's go back here. This gateway knows about a default route through here. Now, keep in mind, I didn't list DRSR, DRSR, but the point is the T1 gateway as a whole knows about a default route to get out. The T0 gateway knows about a default route to get out. And we can actually even get to that 888 address from here. So let's start checking the reverse path. So let's go back to NSX. We're still in that tier 0 SR. Let's pretend for a minute that when this packet down here left to 8888, let's pretend that it actually returned back. Does our tier 0 SR know about our 20 network? Does it know about this segment right here? Does this T0 know that this exists? Let's confirm. Let's check the routing table right here. So we're just going to up arrow and we'll do get route 20.20.20.0/24. That's interesting. Total number of routes, 0. If you don't believe me, let's just do get route and let's just review again, looking for that return path. Do we have a route to the 20 network? We do not. That is really the problem here. If we try to ping 20.20.20.1, we're not getting anything. We see time to live exceeded. In fact, we're getting a result from our physical network. So what's happening is if I do get route 20.20.20.1, we can see this is actually being routed out to the physical network. So it's just getting dropped on the physical network. What we actually want it to do, so if you're keeping track here, traffic is going out through here successfully. And when it comes back, it's doing a lookup here for 20.20.100 in the case of our actual VM. And it's saying, yeah, I got a default route to that. And it's sending it back out to the physical network. That's a problem. So ultimately what's happening here is we're not getting a route on the T0 for the 20 network. So let's use the GUI. Let's start troubleshooting this. So let's go into our networking tab right here. And let's go down to tier 1 gateways. And I'll show you what's going on here. From here, we're going to go to edit our T1 right here. Let's click those 3 dots and hit edit. And we'll scroll down to route advertisement. This is our problem right here. This section right here determines what we will tell our T0 about. And if you're asking which T0, it's whatever T0 you're linked to right here. So this is saying, are we going to tell the T0 about all static routes that we know about as the T1? No, we're not. Are we going to tell it about any load balancer VIP IPs that we have configured? If we've configured load balancing on the T1, are we going to tell the T1 about those IPs? No, we're not. The thing we should really be concerned with here is right here. Are we going to tell the T0 about all connected segments and service ports? No. If I check this and hit save, this is going to start advertising any connected segments that are connected to this T1. In this case, this and this. It will start advertising those from here up to the T0. So let's go back there. I'm going to leave that checked, so we are going to advertise that now. Let's hit save. All right, now that that's done, let's do a really simple check. Let's just go back to our T0 SR. I think that was this one. All right. Let's just run that same command. Look, remember we ran it up here and it said that it's going to route back to the physical network. Let's rerun that. That's a beautiful thing. We can see now we do have a route for it, a specific route for that network, and it's via this IP. So this is internal to NSX. We can see it says downlink. That means it's kind of not going to the physical network. It's going the reverse direction into NSX. We can also see where that route was generated by this right here. We see T1C. If we go up here and look at these flags right here, let's look. T1C, where is that? Look, that means tier 1 connected. So that is ultimately it's telling us that's a segment that is connected directly to the tier 1. All right, so that's good. Now let's try to ping that default gateway. Let's see if that'll work. Okay, so we're not going to be able to ping it from here, and this is actually a great lesson in just, troubleshooting in general. Sometimes things like this, you're going to try to do this and it's not going to work, but that doesn't necessarily mean it's broken, right? So in our case, let's flip around the reverse way. Let's go ahead and, let's use our workstation. We had previously tried to ping that gateway, that default gateway for that segment. Let's just try to do it again. And again, this is from outside of the network. So instead of using my tier 0, I'm going to ping through it into the network. Look at this. It is working now. We can see that we have reachability to that. And I suspect we have reachability to Apple 1A. So let's try to ping that as well while we're here. That seems to be working great. Now our final test is, let's go into Apple 1A and let's go ahead and do one more test. Let's see if we fix this. All right. So previously we tried to ping to our DNS server that is outside of NSX, but not out to the internet. Let's try that since that's right here. We see that's working. That right there tells you that the physical network now knows about this route. So our final test here is, can we ping 888? And we can. All right. So everything's working great. So we resolved this. Now I want to address one more thing. I said the physical network now knows about this segment. How is that? That is because we're now advertising from the T1 gateway all those connected segments to our T0, and we already have route redistribution configured on the T0 to advertise these segments, anything essentially, out to the physical network. That's why this little change we made here fixed everything. All right, that said, in part 2 of this lab, we're going to start troubleshooting Web 01A, because if we go check out Web 01A, we're going to see we're having problems there still. So we will troubleshoot that when we come back in part 2.